I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures, still on enthalpy change. So before us, a typical chemistry A-level question on enthalpy change. A butane burner is used to heat water. The molar mass of butane is 58. The standard enthalpy change of combustion of butane is minus 2877 kJ per mole. 250 grams of water is heated from 12 degrees Celsius to 100 degrees Celsius. The burner transfers 47% of the heat released from the burning fuel to the water. Assume that the butane undergoes complete combustion and none of the water evaporates. What is the minimum mass of butane that must be burnt? So the first thing for us to do here is to calculate the heat absorbed by water, the quantity of heat that is released from the burning fuel to the water. So heat absorbed by water, so we have to use our formula. Quantity of heat released will be equal to what? The mass of water multiplied by what? The specific heat capacity of water multiplied by change in temperature. So the mass of water is equal to 250 grams multiplied by specific heat capacity of water, which is 4.18, which is a constant, multiplied by change in temperature is 100 minus 12, which is equal to 88. So temperature change is equal to what? 88. So I'm to use my calculator. 250 multiplied by 4.18 multiplied by 88. So you get what? 91,960 joules of energy. Convert it to kilojoules, divide by 1,000. So you have what? 91.96 kilojoules of energy. Now this is the what? Heat absorbed by water. Now from the equation, the burner transfers 47% of the heat released from the burning fuel to water. So heat absorbed by water is equal to 47% of what? The total heat release. I use QT to represent the total heat release. So this is the heat absorbed by water. That means 91.96, which is the kilojoule, which is the heat absorbed by water, is equal to what? 47 over 100 times what? The quantity of heat released, the total quantity of heat that is what? Released. So we have to calculate that. We cross multiply. You now have what? 47 QT is equal to 91.96. 91.96 multiplied by what? 100. Multiplied by 100, which is equal to 9,196. So 47 QT will be equal to what? 9,196. Divide both sides by 47. Divide both sides by 47. So to get the total heat transfer, which will now be equal to what? 9196 divided by 47. So you get 195.66 kilojoules approximately. So this is the heat release. This is the total quantity of heat that is what? Released. So we're asked, what is the minimum mass of butane that must be burnt? The minimum mass of butane that must be what? Burnt. And we all know that the standard enthalpy change of combustion of butane is the enthalpy change when 1 mole of butane is burnt in excess oxygen under standard condition. 1 mole of butane is the molar mass of butane. So we are going to calculate what? The minimum mass of butane that must be burnt when 195.66 kilojoule of energy is what? Released. So I'm going to erase this so that I will have enough space. So let me erase this so that I'll have enough space. So when 1 mole of butane is burnt, 2,877 kilojoules of energy is released. And 1 mole of butane is the molar mass of butane, which is 58 grams of butane. Releases what? 2877 kilojoules of energy. Then 195.66 kilojoules of energy will release what mass of butane? So we'll cross multiply. So to get the mass of butane, X now will be equal to what? 58 multiplied by what? 195.66 divided by what? 2,807.77. So I'm to use my calculator. So we'll now have what? 58 multiplied by 195.66 will be equal to 11348.28. Then divided by 2877. So divided by 2877. So you have what? It will now be equal to what? 3.94 gram. So that is the minimum mass of butane that must be burnt, which is 3.94 gram. So the correct answer to this question is what? C. C is the correct answer. As you can see, it's as simple as what? A, B, C. Attempt as many questions as possible and feel free to reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. Thank you very much. I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures. So before us, a typical chemistry A-level question on enthalpy change. Sulfur can be oxidized in two ways. So 1 mole of sulfur react with 1 mole of oxygen to give you 1 mole of sulfur dioxide, and the enthalpy change of formation is minus 295.5 kilojoule per mole. Then 2 moles of sulfur react with 3 moles of oxygen to give you 2 moles of sulfur dioxide. The enthalpy change is minus 791.4 kilojoule per mole. Sulfur dioxide can be made from sulfur dioxide and oxygen. So 2 moles of sulfur dioxide react with 1 mole of oxygen to give you 2 moles of sulfur dioxide. What is the standard enthalpy change for this reaction? So we have to calculate the standard enthalpy change for this reaction. So enthalpy change of formation of sulfur dioxide and enthalpy change of formation of sulfur dioxide is given. So enthalpy change of reaction, standard enthalpy change of reaction, standard enthalpy change of reaction will be equal to what? Enthalpy change of what? Standard enthalpy change of formation of the product minus enthalpy change of formation of what? The reactant. The reactant. And please take note that enthalpy change of formation of an element is 0. So to calculate it, standard enthalpy change of the reaction, the product is what? Sulfur trioxide, which is 2 times sulfur trioxide, which is 2 bracket minus 791.4 minus enthalpy change of formation of the reactant, which is 2 moles of SO2, which is 2 bracket what? Minus 295 point minus 296, not 295, 296.5 kilojoule per mole. So the enthalpy change of the reaction, so I'm to use my calculator. So you have minus 1582.8 minus bracket minus 593. So the enthalpy change of reaction now will be equal to minus 1582.8 plus minus times minus to give you plus, so plus 593, which will now be equal to, so I'm to use my calculator now. So you have what? Minus 989.8. So minus 989.8 kilojoule per mole. So the correct answer to this question is what? B. which is minus 989 kilojoule per mole. So it's as simple as ABC. Attempt as many questions as possible and feel free to reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures, still on enthalpy change. So before us, a typical chemistry A-level question on enthalpy change. 200 grams of water are at 25 degrees Celsius. The water is heated to 75 degrees Celsius by burning 2 grams of ethanol. What is the amount of energy transferred to the water? So I have to calculate the quantity of heat released. So when 200 grams of water is heated to 75 degrees Celsius by burning 2 grams of ethanol. So the quantity of heat released, Q, we use Q to represent the quantity of release. Q is equal to what? Mass of water multiplied by specific capacity of water multiplied by what? Change in temperature change. So quantity of heat released is equal to the mass of water is 200 grams multiplied by the specific capacity of water, which is 4.18, multiplied by what? The temperature change, which is change in temperature is 75 minus what? 25, which is the final temperature minus the initial temperature. So quantity of heat released. So I'm going to use my calculator now, which is okay, it will now be 200 multiplied by specific capacity of water, which is 4.18 times 75 minus 25, which is 50. So we'll have what? 41,800 what? Joules. So to convert it to kilojoules, divide by 1,000. So you have 41.8 kilojoules. 41.8 kilojoules. So the correct answer to this question is, the correct option is C. C is the correct answer. So it's as simple as ABC. Attempt as many questions as possible and feel free to reach out to me if you encounter any challenge or any difficulty. I'm Mr. Joseph, your chemistry teacher. I'm always there for you. Thank you very much. I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures, still on enthalpy change. Before us, a typical chemistry A-level question on enthalpy change. Using the information in the table, what is the enthalpy change Q for the reaction described? The equation before us is the equation for the lattice energy of cesium bromide. From the equation, 1 mole of gaseous cesium ion react with 1 mole of gaseous bromide ion to give you 1 mole of cesium bromide. You are given the enthalpy change Q, which is kilojoule per mole. The standard enthalpy change of solution of cesium bromide is plus 25.9. Standard enthalpy change of hydration of cesium ion is minus 276. Standard enthalpy change of hydration of bromide ion is minus 335. So you're asked to calculate the enthalpy change Q, which is the lattice energy Q. Is equal to the lattice energy. And the equation, the lattice energy will equal to what? Enthalpy change of hydration. Enthalpy change of hydration minus what? Enthalpy change of solution. So Q now will be equal to what? Enthalpy change of hydration is minus 276 hydration of cesium ion plus bracket minus 335, then minus what? 25.9, which is the enthalpy change of solution. So I'm to use my calculator. Minus 276 plus minus 335. So you have what? Minus 611. Then minus 25.9. Minus 25.9, which is equal to minus 636.9. Minus 636.9. So the correct answer to this question is what? A. A is the correct answer. So as you can see, it's as simple as ABC. Attempt as many questions as possible and feel free to reach out if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. Thank you very much. I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures, still on enthalpy change. before us a typical chemistry A-level question on enthalpy change. Two reactions are shown. The first one is the bond energy of hydrogen. The second is the enthalpy change of combustion of carbon monoxide. If molar amounts are used, how can the two energy changes associated with these reactions be described? So we're going to look at the options. So if you look at this is the bond energy for hydrogen, bond energy of hydrogen, and this is what the enthalpy change of combustion of carbon monoxide. 1 mole of carbon monoxide is burnt in excess oxygen under standard conditions. So we're going to look at the options. Option A, enthalpy of atomization and enthalpy of combustion. No, A is wrong. A is not the answer. Then if you look at B, enthalpy of atomization, enthalpy of formation. No, B is wrong. B is not the answer. Then if you look at C, bond energy and enthalpy of combustion. Yes, C is the correct answer. Then if you look at D, bond energy and enthalpy of formation. No, D is wrong. So the correct answer to this question is what? C, which is the bond energy of hydrogen and the enthalpy of combustion of carbon monoxide, CO. So it's as simple as ABC. Attempt as many questions as possible and feel free to reach out to me if you encounter any challenge or any difficulty. I'm Mr. Joseph, your chemistry teacher. I'm always there for you. Thank you very much. Mr. Joe, your chemistry teacher. Subscribe to my YouTube channel, comment, like, share, and reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joe, your chemistry teacher. Subscribe to my YouTube channel. Thank you very much.